Today we are going to discuss about embedded system and IoT. Unit 2 ARM processor. What is an ARM architecture? ARM architecture is a family of RISC-based processor architectures. It is well known for its power efficiency, widely used in mobile devices such as smartphones and tablets. It is also licensed and designed to wide ecosystem by ARM. The ARM Holdings companies designs ARM-based processors. It does not manufacture license but licenses designs to semiconductor partners who add their IPs on top of ARM processors. Next, ARM Cortex M3. The ARM Cortex M3 has an ARM core. It has a memory production unit, serial wire weaver. It has a flash patch and data watch points. The flash patch is used for memory, and data watch points is for controlling and watchdog timer. It has an SRAM for serial RAM, peripheral interface, and a code interface, DAP and WIC. Next, features of ARM Cortex M3. The features of ARM Cortex includes it is a hardware architecture. It has three-stage pipeline with branch speculations. It has an NVIC nested vector interrupt controller and wake up interrupt controller WIC. The wake up interrupt controller is very useful for ultra low power standby operations. It minimizes the power consumption of the overall device. Next, extended configurability of debug and trace capabilities. It is more flexible for meeting specific market requirements. It has an optional components for specific market requirements such as memory production unit MPU, embedded trace macro cell ETM. It also supports for fault robust implementation. Next, exceptions in ARM processor. Exception is a condition that needs to halt the normal sequential execution of instructions. There are five types of exceptions. First exception is the fast interrupt request. It operates in the FIQ mode. The main purpose is to fast interrupt request handling. The second one is an interrupt request IRQ. It is used for interrupt request handling. Next, SWI and reset. It is an SVC mode. It is used in protected mode for operating systems. Prefetch abort and data abort. It is an abort operation. It is the main purpose is used to virtual memory or memory protection handling. Next, last one is the undefined instruction. It is an undefined mode. The main purpose is to software emulate of hardware co-process. Interrupt handling. The ARM processor has an interrupt handling. There are two types of interrupt handlings, IRQ and FIQ. As already discussed, IRQ is interrupt request, FIQ is also an interrupt, SW instructions. When the interrupt is of software side, they are normally reserved to call privileged operating routines. Example, they change a program running in user mode to a privileged mode. Next, interrupt requests are normally assigned for general purpose interrupts. IRQ exception has a lower priority and higher interrupt latency. FIQ has a fast interrupt requests are normally used reserved for a single interrupt source that requires a fast response time. The peripherals and the timer unit. The LPC 214 is an ARM processor. It has a timer. The timer features includes the timers are counter 0 and timer or counter 1. They are bit identical except for their peripheral base address. It is a 32-bit timer or counter with a programmable 32-bit prescaler. It can operate as a counter or timer. Next, ADC. ADC, as we all know, ADC is an analog to digital converter. The ARM processor has a 10-bit analog to digital converter, out of which two analog to digital converters. It is a 10-bit successive approximation ADC, which converts the analog signals to digital signals. The ADC 0 has 6 channels and the ADC 1 has 8 channels. The features include 10-bit successive approximation unlocked digital converter. It has a measurement range of 0 volt to V reference voltage. It can be able to convert values up to 10-bit samples. It has a dedicated result register to reduce interrupt overhead. It has also burst conversion mode for single or multiple inputs. 10-bit DAC. DAC, digital to analog converter. It has the features of buffered output, power down mode available. It can be able to generate a variable analog output. The maximum DAC output voltage is the reference voltage. UART. UART is defined as universal asynchronous receive transmit. In addition to standard transmit and receive data lines, the LPC 214 or 248 UART provides a full mode control handshake interface. It has the features such as receive transmit, 16-bit receive transmit. It is built-in fractional baud rate generator. It has the receiver FIFO, fast in first out trigger points. It has a transmission FIFO control enable. Next, UART block diagram. The UART block diagram includes the variable interfaces. Next, I2C bus. I2C is an inter-integrated circuit bus. It is a bidirectional bus. It is used for serial clock and serial data pulses. It has two wires, SCL and SDA. It is a serial clock line and serial data line. Each device is recognized by a unique address and can operate as a receiver device. Example, LCD driver or transmitter with the capability to both receive and send information. The transmitter or receiver can operate in either master or slave mode. The I2C bus as a multi-master bus, it can be controlled by more than one bus master connected to it. It supports bit rates up to 400 kilobits. I2C bus. It has a pull-up resistor on both SCL and STL line. The ARM LPC 2148 is connected to the SCL and SDA line with the other devices with I2C interfaces. Serial peripheral interface SPI. The serial peripheral interface is also one type of interface. It has a SPI shift register, SPI state controller, output enable logic, SPI register interface. It has MOSI. MOSI means master output slave input. MISO, master input slave output configuration. If a device acts as a master, other devices will act as a slave. Thank you.